All right, I think I'm going to start here. I have a lot of content to cover. Thank you for coming to my session, and it's a pleasure to be here. That's my first time in Copenhagen. It's a nice city. So here's our agenda. I'm going to talk about the Cosmos DB and how to make it more, scalable, hopefully more affordable with this, presentation. So our agenda is kind of looks like there's not that much out there, but actually there's a lot of slides here. So before I start, I guess let me talk about myself. My name is Hasan Savran, and I am from Cleveland, Ohio. I'm a Cosmos DB SME. You might be seeing me on the, YouTube or any other events. Usually I talk about the Cosmos DB, SQL Server. I'm a data platform MVP too. So I'm really happy to be part of the program. I developed the Cosmos DB SQL Studio. You can actually download that from that barcode, or you can download directly from the VS Code if you like. And if you will have any questions after this session, please follow me from the LinkedIn or the Twitter. I will be more than happy to help you from there and answer any of your questions. Now, let's talk about the Cosmos DB. First, I guess we should talk about the physical partition of Cosmos DB because that's usually where the biggest problems are. In the physical partition, when you actually create, let's say, one web application, Cosmos DB gives you one database server. And, well, we call that physical partition. So this server has actual limits. There are two numbers here. One of them is the storage limit, 50 gig storage, and the other one is the 10,000 request unit per second. That's really the horsepower that it can give you the maximum. So as your data is going to get larger and your application is going to get busier, one of those numbers, the number is going to get close to, storage is going to be 40, 45, and as soon as it's going to get hit to that number, Cosmos DB is going to actually give you more database servers depending on your needs. So this is the horizontal scaling. That means that, if you get close to 50 gig, we are not going to try to make this database bigger. We are going to give you another database that you can use. So you might guess, how big we can get with this. I was actually watching that video from the Cosmos DB, and they share this information. I don't know if you know or not, but ChatGPT is actually using the Cosmos DB in the backend. So these are the numbers that actually they deliver in that video. So as you can see, the first one is giving you the number of the transactions. Those are the billions. So in March 2023, we are looking like 2.3 billion of transactions Cosmos DB was handling. And as soon as they actually put some more bundles and features, you can see that that number kind of go crazy from there. In November, we have like 10.6 billion transactions. And also, if you look at the physical partitions, those are actually respecting those numbers. They are going high with the transactions. So in November 2023, we have 25,000 partitions, which is database servers, just for the ChatGPT. And it looks like the partition key is the user ID, which makes sense. Whenever you do something with the ChatGPT, you have the user ID, so you know which partition has the, the data, so everything kind of scalable very easily. If you pick the wrong partition key, you are really in deep trouble here because we have like 25,000 partitions here to deal with. And also, by just looking those numbers, I said that, we have like 50 gig, that's the limit of a per partition, and also we have 10,000. So by just looking at the, the physical partition, you can easily figure out how many actually transactions are getting handled by one physical partition. And that's going to give you the last one, which is the right now 424,000 handled by one physical partition. Also, my other guess here is in the right corner here. So if each physical partition is half full, that makes 625 terabyte of data is getting processed in November 2023. So I'm not sure what is the latest, but probably is much higher than that right now. So Cosmos DB is easily very scalable, and it can handle global application like that very easily. And also, they didn't have to kind of go change those things in the outer scale. Actually, let's get outer scale up. So Cosmos DB is actually controlling the scaling, the traffic, and the partitions. Now, not everybody has ChatGPT, right? So our applications are usually smaller than that. So let's say we have a simple application, and we are just keeping orders in one container. We pick the customer ID, and looks like we have 202 gig of data. By just two numbers that I just talked about, the 50 gig and 10,000, you can easily read this diagram and make decisions on it. For example, we have one physical partition, looks like it's 44 gig. That is going to get split soon, and you know that this is going to split, and we are going to have another database server, and half 22 gig is going to stay here, and we are going to have another one with 22 gig. That is important because right now it looks like we have 10,000 request units per second, right? 10,000 request units per second actually can deliver all these operations per second. So that's really not like a small application. It can handle all those in per second. If you are going to have one more database server, though, that numbers might change. For example, as it is right now, each physical partition has 2,000 request units. Your total is 10,000, so it's divided by the number of physical partition. If you are going to have one more, then that means each of them is going to have like a lower number. So that's why it's important to kind of watch which physical partition is going to get split, so you can kind of be on top of if something goes wrong, you will know it. Also, looks like frequently queries out there has the partition key in them. So that is really great. Well, meet my friend John. John feels good because, well, everything is working great here. He created a good, architecture here. And as long as, customer ID is out there, this is going to scale well and it's balanced. So maybe John's manager see that, well, Cosmos DB is, looking promising. So maybe he's going to give another project to another developer. So other developer, the project was, well, we don't have the customer ID anymore. But maybe the other developer is not really familiar with the Cosmos DB that much. So if we are going to use the same structure that actually John created, well, we have a problem here. Because, well, we don't have the partition key available in this case. And if we are going to actually not catch this and go production with it, you probably break the other one, which is actually working, because this select statement is going to go in every partition you have. And, well, you're going to be in trouble because you're going to start to use the memory and the CPU of each server, and it's going to bill you for that. Then that means you potentially broke the other one because this one is going to need more resources. And also this one is going to use resources that you really don't have to. Well, my friend Joe here is really confused because when this happened, you're going to have like a huge bill coming up, and your manager is not going to be happy with this. Now, I see this a lot, and when this happens, there are a couple of things you can do. The first thing you can do is probably the change feed function. In change feed function, all you are really doing is you are duplicating the data to another container with a different partition key. So in our case, we have orders container, and our partition key is customer ID. The first step we are going to do here is we are going to create another container, and let's call that orders under product, with a different partition key that actually we have. So product ID is the one that we were trying to use. Then we are going to actually move that data from orders to the orders product table, so they kind of get sync. We have the same data, duplicating the data here. Now, we are going to use the change feed function. Change feed function is available in the NoSQL, Cassandra, Mongo, and Gremlin APIs. When change feed function happens, we prefer to use the Azure function. And Azure function is going to get triggered every time there's a data change in our orders container. So from here, you can really do anything with the Azure function. But in this case, we are just going to take this data and sync it to the orders product. So that's how we are going to keep the sync between two containers. You are going to get another insert charge here, which is fine because you are really going to save in long term, because in this case, the query is going to be different. One of them, if you have the order ID, you are going to look at the orders container. If you have the product ID, you are going to look at the new container. So by duplicating the data in NoSQL databases is the cheapest way to kind of handle a situation like that, rather than you try to repartition or try to find a perfect partition key in NoSQL databases, included Cosmos DB. Another option that might actually save you a lot is point read function. Point read function is available, and it can retrieve only one document. It will not be like a query. And it was the fastest and cheapest way to actually get a document from Cosmos DB. So as you can see, there are some requirements here. First one is the partition key. It is required. And also the document ID is required to actually execute a point read feature or operation. If you compare that to the query, in query, if you need more than one, then you must need to use the query. And as you can see, request charge, let's say our JSON data model is maybe 1 kilobyte data. That is going to cost you, if you use the point read, 1 request units. In the query, it's going to cost you at least 2.3 or higher. And the main reason for that is for a query to run, you need to run the execution plan, which point read doesn't even need that. So that's one of the main reasons. Point read is much cheaper. So here is, for example, what query looks like and what point read looks like. They pull exactly the same document, but one of them is cheaper than the other one, which is the point read. And you can do the point read only from the SDK, so you cannot run that from as a query. Next one is connecting the Cosmos DB. So Cosmos DB is a cloud database. So sometimes, depending on your, I guess the IT structure, firewall settings, it can be kind of sometimes challenge to connect the Cosmos DB. So we have the first option, gateway mode. Gateway mode is really we just put one server between your application and the Cosmos DB, and your application actually connects to the server first, and server is the one which actually retrieves or inserts the data for you. And you almost like create this network hub between the Cosmos DB and your application. So I guess the first thing to know when you use this, you are actually using the HTTPS and the single DNS point. Many companies use this because it might not be easy to change your firewall settings or opening new ports. So this is really the easiest way to reach the Cosmos DB without kind of going to IT and try to, I guess, involve the security and all kind of stuff. That can get long, I guess, from there. But as you can see, this server is actually getting shared by other Cosmos DB customers. So that is really not your server, but that is why it's free, I guess. And the other thing to know, we have an inactivity limit here. So if you are not going to use that connection 2 minutes, that's going to get disconnected. SDK will re-enable that, but we will see in a little bit, actual opening ports or opening connections can be costly in Cosmos DB. And also, since this is an HTTPS, just like any other browser, when you kind of try to connect to the applications, you have a limited number of connections, which is usually 50. If you want to change that, you can easily do that by changing the documents.client connection policy and max connection limit. That number can go from 100 to 1,000, and you can actually make that connection much larger if you need to. Next one is the direct connection. Direct connection is the default way that from the SDK using the Cosmos DB, using the direct point. So that's a long live connection. That means that you don't have a 2-minute limit anymore. And it's using the TCP, using TLS, so it's pretty secure. But because of that, you might actually need a firewall change, or you might need to kind of go and open new ports to make this available. And in here, as you can see, we don't have a network hub anymore. We don't have a server in between your application and the database, which makes things much faster and quicker. This is available only in .NET SDK and Java SDK. If you are using the version 2, SDK 2, you can actually override that. As you can see here, I'm doing it for the Cosmos client. You can easily do that to direct, because SDK 2's default way to gateway rather than direct. Next one is dedicated gateway mode. This is the same idea with the gateway mode, but as the name suggests, this is your server. And well, since it's your server, you have to buy it, right? It's not free anymore. So to actually be able to use that, first you have to go to dedicated mode and buy a size of a server. Just pick it wisely because you cannot change the size later. As soon as you have that available, the connection string will be available under the keys. And just use that connection string to be able to use the dedicated mode. And really, you might ask now, why do I need to do that? The other gateway is free. Why do I want to pay that? Well, first of all, this is yours, so you are not really sharing with anyone. But also, actually, in dedicated gateway mode, it gives you a little bit more features, like caching data. If you have an application and you are always using the same data again and again, well, caching might be really a good point for you to actually save some bills with the Cosmos DB. As you can see in here, the first one, our application is trying to read or query the data. It goes to our dedicated gateway server. Server is the one which is getting the data and pulling it back. When we do the same request next time, then that's going to cost us 0 request units because, well, we already cached that data. And if your data is not changing in your application, and if you are trying to read the same data again and again, this will save you a lot of request units. The only, I guess, the thing that you really need to watch is the consistency level. Your consistency level must be session or eventual for this thing to work. If it's something else, it might not work. But what you can do is, I'm not really saying go and change your database's consistency level. You can easily change your query's consistency level and make this run if you really need them. So how do we make this work? First of all, you need the SDK 3.2.1 or later. Then, as I said before, we have the dedicated gateway right here. First, you have to go here and pick your server size. As soon as it becomes available, it will be under the keys. You just take your connection string from there and put it in your web config or wherever you are keeping your keys, and you are ready to go. So from here, first of all, as I said before, the direct mode is the default mode of SDK3, which is the last one right now. So that means that you have to go and override your connection mode by using the connection string here. So as you can see, I'm picking the connection mode gateway. I'm forcing that for this connection. Then looks like this is the query I'm running. So to make the caching work, I have this request options here. First of all, I want to be sure that consistency level is a session or eventual. In here, I just keep it eventual. If your database is consistency level session or eventual already, you don't really need this one. Then you kind of need to tell Cosmos DB how long you want to cache this data. So it looks like I am caching this for 30 minutes. And this new one here, I just commented out. That one is actually a new one. It's still in, I believe, private mode right now. And if you, for whatever reason, if that function, you don't want to get the data from the integrated cache, you can easily control that with that function. You can make it true or false, or maybe only one function will always come from database, even the data is available in cache. So you can control that with the bypass integrated cache parameter. So as you can see here, the first time when we run it, it returns 592 documents, cost me 32.25 request units. When I send the same request in next 30 minutes, it's always going to cost me 0 request units. So yes, you're going to pay for the server, but if you are reading the same data again and again, this can actually save you a lot of request units, and it will be useful. Next one, let's talk about the Cosmos DB SDKs. Cosmos DB SDKs do actually much more than other SDKs of databases, especially like if you think about the SQL Server. Really, in the other SQL Server, usually like all the aggregation, all the the group by, sort by, all are done by the database engine. Cosmos DB doesn't work like that. Well, I guess it cannot work like that because it has many physical partitions. The data is not centralized place. So, for example, we have 10 servers here, right? Looks like we have all the orders, and I want to get top 10 orders, and I want to order by the view count property. Well, if you really think about it, well, I don't have the partition key here too. So that means that I am going to send this query to every physical partition I have, which means the data is going to come from all of these places. And the database cannot do the top 10 or the order by because it doesn't know what other physical partition data it has. So it needs to come to the Cosmos DB SDK, and SDK is the one which is going to actually eliminate 90 of the properties. It's going to give me the top 10, and also it's going to order by the view count. So all the aggregations actually happens in the SDK, which means probably there's all kind of loops happening out there, all kind of resources it's going to need. So you want to be sure that your SDK, wherever it runs, it has good amount of like resources, because it's pretty busy. It's doing a lot of stuff there. So if you actually see, this is the JavaScript SDK. And if I try to run the same one here, as you can see, in the left side, we have that query info object, and which actually senses what kind of aggregation you might have. And it kind of finds, for example, it finds the order by here, and also it finds the top 10 out there. As long as there is something out there, it actually rewrites your query. So my query end up with the one in the right side you see on the top. So that kind of helps to, the SDK, when the data comes back, it can easily order by or do the aggregation for the SDK. But that's what happens in the backend. Next one, if you are using the .NET SDK, there are a couple of things that you should know. The first one is you want to be sure that your project is in 64-bit, not any CPU or 32-bit, but 64-bit. Main reason for that is 64-bit is the only one which has a service interrupt.dll file. This file can create the query plans locally. That means you don't have to make a request to Cosmos DB for a query plan. So you save one request by just making your application 64-bit with this. Next one, for the garbage collection, you want to be sure that you are using the server mode rather than workstation mode. And you want to disable the default trace listener. Sometimes it can be a bottleneck for the CPU and I/O in production. And if you are testing your application, and your application is like 40 or 50,000 request units or more, one machine is not going to be able to actually handle that, because that's pretty high request units. You might want to test your application with multiple servers. Because if you're going to do that with the 40 or 50,000, since the application or the server is not going to be able to handle that, you might end up with 429s and all kind of weird problems, which there's really no problem, but your server is the one which cannot handle all the requests and responses. So you want to be sure that you have multiple testers, test workstations. Next one is Stream API. This is available in SDK 3. And if you are try to use it to make actually more scalable and smoother, because as you can see in SDK 2, usually what we do is we serialize the data, then deserialize the data when we actually give it back to the application. So that's like two kind of, the ways. So in SDK 3, it's much smoother, just almost like the direct mode and the gateway mode, really. We don't have that hop in the middle here. So for example, let's look at the old one with the SDK 2. This is the most common one. So as you can see, we have a list of sales. So every time we are actually creating a sale here, we are doing the serialization. When you are actually done with that and try to give back to the application, usually you convert this to JSON object. So that's going to be the deserialization. So you are doing like two steps here. You can easily make this more simple by using the Stream API. So in Stream API, as you can see, we are really creating like a JSON text reader here, and we get the data as JSON, and we return it as a JSON. So rather than having like two, the steps, this is just one step. The only catch up here is you must need the partition key for this thing to work. Without partition key, it's not gonna work. So that's the only, requirement for Stream API. Next one is the document client. Document client is how you actually access the Cosmos DB. My suggestion is you want to use the singleton when you do the document client, because the last thing you want to do is create a new document client for every request. You want to create one document client and use for all other calls to the Cosmos DB. Main reason for that is actually, let's see what happens when you declare or initialize the document client. The first thing Cosmos DB is going to do is going to request your account information. After that, it's going to get all the container information. That's another request. Then it's going to get all the partition and routing information. So we are talking like 3 requests here. We haven't even made any kind of request for any kind of query yet. So if you're going to do this, then that means you are actually calling Cosmos DB 4 times to run a query. So you want to execute this once and use it with the singleton and use the same document client for all the requests. Here we can talk about actually the consistency mode, which I just want to touch it because that's a big topic. But the consistency mode is going to actually help you or the help application to figure out where this data is going to come from. So as you know, in the Cosmos DB, we have, let's say in one the physical server, we have actually 4 servers in it. We have 1 leader and 3 followers. So it's a node set. So consistency mode is going to actually figure out where this data is going to come up, because if you really think about it, you have 4 places to pull the data from. So depending on the consistency mode, document client is going to pick that data from a leader, or from the leader and follower, or just the follower. So that's where the consistency mode is going to actually happen. So from here, it just pulls the data, and well, you get the data after that. Next one is metadata requests. So depending what kind of application you have, you might be creating dynamically containers, databases. Maybe you want to list all the containers in a drop-down. So all of those are actually metadata requests. And you don't really use your threshold you pick for the request units. So let's say if you have 1,000 request units, when you try to get a list of databases, you don't really use those request units. There is a system reserved request units only for the metadata requests, and which is 240 request units. And there are some limits, as you can see out there. There's like maximum collection create is 100 per minute. So you cannot create more than that. Even you want it, you cannot do it. So if you are doing things like that, you want to be sure that you cache this information as much as you can, because that 240 request units you have out there, you cannot change it. So I guess just be careful with that. And yeah. Next one is optimizing the bandwidth. So in here, many times when you try to insert data, for example, I'm not sure how big your data model is going to be. Let's say you have like 10 kilobyte data model. You insert it, you send it to Cosmos DB. And when Cosmos DB actually gives you a response, usually what you need is, okay, this is success or not. Usually that's what you care. But when Cosmos DB actually gives you the response, it actually attaches your data model, your insert request to the response, which makes the packages much bigger. So you can easily control that by using the enable content response on write parameter. If you make this false, that means that object will not be attached to the response, and the packages will be much smaller, and actually that will help you, especially if you are doing any with the bulk mode things. So this will actually help you. Next one is partial document update. This one is a newer function. And you can do all kinds of things with this. If you don't use this one, and if you, let's say you have a property and you have a flag, you're going to change it from true to false. If you don't use that, you have to send the whole data model to the Cosmos DB, and Cosmos DB needs to figure out what is changed and change only that one. In here, you can easily say that I want to change this property to this value. So really, as I said before, with the packages, your request is going to be much smaller, and it's going to be much faster. This is not going to cost, I guess this is not going to cost less request units. It's going to really cost you the same, because if you really think about it, Cosmos DB is still going to open that and change it and save it back. But it's going to make, I guess, developer side is much easier. And also, you can actually combine operations here. So it doesn't have to be only one property. You can have 2 or 3. This one supports the transactional batch. So you can actually keep that with the transactional batch, and also conflict resolution support is there too. So those are the operations we have: add, set, replace, remove, and increment and move. We have the increment here, but if you actually pass a minus number, you can decrease a number easily. So if you have, for example, number of orders and you want to increase it or decrease it, you can say 1 or -1, and you can do it easily like that. So let's look at an example here. The first one here, it looks like I am creating a list of patch operations. The first thing I'm doing is I'm adding a totally new property named sale date, and I'm just passing today's date, and I am removing the original sale date. So when I run that, as you can see, I am going to need the document ID and the partition key for this thing to work, and pass my patch operations. So that's how it works. That's the basic one. Another interesting option this one has is actually a filter. So in here, as you can see in the options, I am actually passing a filter predicate. And it says that I want this update to go through as long as this is true. So if the number of items property is larger than 5, this update is going to go through. If not, Cosmos DB is not going to update it. So it looks like what we are doing here is I am adding a new property named audit, and I make it true as long as the number of items is larger than 5. So with one operations, I can actually do both together here with the partial update. All right, next one is indexing. Indexing is important. In any databases is important. So when you actually create a new container in Cosmos DB, well, Cosmos DB indexes everything. So you don't need to worry about what I should index. So many people like it, but they figure out that maybe that is really not a good option when your data is going to get larger. Especially you have like a data file, which you keep all the data, and you have an index file, only one index file. So if you are going to actually index everything, that means your index file might get larger than your data file. And if you are, for example, let's say you have a property name description, that is never going to be in your where clause, but you are still indexing that. So you should kind of exclude properties like that later when you figure out what you are filtering by. So we have 3 indexing modes in Cosmos DB. Default is the consistent. That's really I guess the consistency between the data file and index file. When you say consistent, that means that your data and index file always matches perfectly all the time. As long as data changes, index changes immediately. If you make this lazy, which is really dangerous one, which means that the data file the actual index file eventually match the data file, which means if your data is actually coming from the index file, potentially you might return wrong data. So you don't really want to use the lazy. Lazy is actually a little bit cheaper. That's many people uses that for, but it's really not worth it. So if you are using lazy, just go back to the consistent because it's worth it. And also none, that means you don't really need indexes. Usually you do that when you bulk load any kind of, maybe that's the first time you are pushing the data. You don't need indexes because that's going to make things, slower. You just put the data in database first, then figure out what needs to get indexed later. So that will be a faster way to actually push the data first time to Cosmos DB. So there are a couple of index types in Cosmos DB, and the first one is the range indexes. So the range indexes is really covering most of the filters, equal, not equal, range, any kind of order by, join, everything is handled by the range indexes. We have composite index, which can be sometimes confusing because it has a lot of rules out there you need to follow, but they are very useful if you have a lot of filters in your where clause, or if you need to order by the multiple properties. Actually, you must have the composite index if you have multiple properties in your order by. We have the geospatial indexes. Those are available only for geospatial data. So as I said before, everything is indexed, but if you have a geospatial data index, that will not be created automatically. So you have to actually create those geospatial indexes yourself. And the new ones we have is the vector indexes. SQL API actually supports the vectors now, and you can easily kind of index, and this index will get used by the vector distance system function. So this is still in preview right now, but it's available. You can control the dimensions and the types easily with that index. So as I said before, the composite indexes can be challenging because, as you can see out there, you want to be sure that everything is in the composite index when you create it. It has to be in the same order when you are actually putting them in the where clause. So for example, let's look at some of the composite indexes I create here. The first one you see here, my composite index, I create an index on name and age properties together. And if you look at my query, I am using them in the same order, the name and age, so composite index works just great with this one. Next one, I am using the same composite index because this time the age is not equal anymore, it's larger than 18, which is a range filter. But in composite indexes, all the range filters must be the last one last decay in the composite index. Because of that, it works. So if my composite index was h, comma, name, this actually will not work. Next one I have here, another kind of aggregation I have, that one just works with the name and age composite index. Also, I have the name and age. As you can see, everything works here until we have this select all from C, where C name is not equal to John. That doesn't work because, well, it's not equal anymore, so it's almost like the range. So I have two kind of range filters here, and you cannot use the composite index for this one. If you want, you can create multiple composite indexes. For example, if you look at the select all from C name is John, and I'm passing the timestamp here, but the first one is not working because the range index in the middle, not in the bottom. But in the other one, it works because I actually have two composite indexes here. So that actually handles both of them together. So composite indexes can be tricky. I guess test it in QA and be sure it's working. Then push to production because, well, when you push to production, reindexing can take a long time because you have many physical partitions out there and it's get reindexed. So you want to be sure whatever you are pushing, you are making the right choices with the indexes. So, as I said before, you want to exclude if you are not filtering by any properties, because that's going to actually improve the write performance, because, well, Cosmos DB doesn't have to make the changes to the index file. It's going to reduce the request units charges for the inserts, and it's going to reduce the index storage. So in Cosmos DB, you pay for request units and you pay for the storage. So if you are not going to index things, that means less storage, that means cheaper, which is good. And you want to do all the indexes change together. So if you, for example, compare the SQL Server, you do this index first, that index later, maybe third one later. So if you need to make 3 index changes in Cosmos DB, you want to actually make that policy change together, because, for example, we see that ChatGPT has 25,000 partitions. Well, when you push a index change like that, you are actually doing 25,000 reindexing. So that can take time, that can take resources. So that's why you want to make those changes together in Cosmos DB. Next one, this one is actually a new one, brand new one, competed properties. So, this is a NoSQL database, and, sometimes you have to use the lower function because I guess the post type here must be, answer anything like this. So when you actually run that, this is a function. This function is going to be costly for you, and the system function is going to be costly. In this case, it is like 23.25 request units. You can easily create a competed property, and they are under here, the competed properties tab here. In here, it looks like I have 2 competed properties. One I'm going to demo is the second one here, the C post type. As you can see, I am running the lower for that one. So that is going to actually create a new property, a virtual property, CP underscore post type. And if I'm going to use that CP underscore post type, rather than running the function like that in the first one, this is going to actually drop, almost the halfway with the 13.75 request units. So you can actually use the competed columns if you are using any kind of system functions in your where class. And if you create a competed properties with that, you can easily save some request units in the Cosmos DB. The first one here, as you can see, I'm using the date time different. So if you have anything like that, you can easily use that too. Next one is throughput. So the default one with this one is the provision. I guess when it comes to the throughput, I try to explain that to you. Let's say we are actually throwing a pizza party, right? And you don't know how many people you're going to come to your pizza party. Or maybe you know exactly how many people are going to show up. If you know how many people are going to show up, then you're going to go with the provision and order just right amount of pizza for everybody to use. So that's just the provision works. So you're a web application, or any kind of service, you know how many people are going to come to your application, you know exactly request units you need. Auto scale is great. I try to use it as much as I can, and that scales your application up and down easily. In this one, you are actually giving Cosmos DB a number that you want to go up to. For example, maybe normally your application works with 1,000 request units, but tomorrow is a big sale day, and you maybe it's going to go 5,000, 6,000, you don't know. So you said, okay, I'm going to put a 10,000 here, so it can go up to 10,000 as long as people start, like coming to the application. So it can easily do that for you if you pick the auto scale, you pick a large number, and application scales up as long as it needs and as long as it reaches that number. The only thing you want to be careful with the auto scale, just pick something that you can actually afford. Just don't pick something like 100,000 request units. And because what can happen is somebody can attack your application, right? If that happens, then that means you might actually hit that number and you might end up with a surprise bill next month. So you want to be sure that whatever you pick here is something you can afford. And serverless is the one right now. Actually, there's an update for that one right now, which you can create a serverless. If this is the first time you are creating the application, you don't really need, I guess, request units per second. You maybe pick 1 million request units, and each time you use the Cosmos DB, it will subtract that from 1 million. So you can easily start your application with that. And now, actually, there's a new function. You can actually convert your serverless to the provision, if you like. So if this is a new application, you can just start as a serverless. When you are ready to go to production, you can maybe convert to provision. This works great with the Azure Functions too. Maybe you are running that Azure Functions a couple of times a day. It doesn't have to be provision, so you don't have to pay per second. You can go with the serverless, and that will actually save you some money with the Cosmos DB. Also, I know that you come here, you try to save money and try to make the Cosmos DB bills cheaper with learning some tips and tricks. But there's one actually option here that you don't have to change anything, and it will actually save you money, which is the reserve capacity. If you know you are going to use the Azure Cosmos DB in the next 1 year or 3 years, then you can easily pick the reserve capacity, and that will give you 20% to 30%, depending the number of years, a discount. So you don't have to change anything. You can just use that. This number here is between 100 to 1 million request units. If it's higher than that, believe me, that number actually even goes higher than that. So it can go up to 50, 60% if you are application using more than 1 million request units. That becomes a variable. So that's the easiest way to save money with the Cosmos DB without changing any code. If you are sure you are using the Cosmos DB long term, that's the way to go. Next one is, this one is in preview too. So you might be dealing with some 429, since the Cosmos DB is a rate limited, sometimes you might be hitting that rate limit. And let's say maybe you have 20 transactions going on and you want to be sure that maybe 18 of them is really high, that too, if that fails, you don't care. So you can now actually control which should be the high and which should be the low by using the priority-based execution. So by default, everything is high. So you can try to keep which one is low, or you can keep the high and make the the lows, I guess, nullable. So in here, that's an example here. So it looks like I am trying to create this transaction. Looks like I'm creating a Stack Overflow post and just making this priority level high. This will be prioritized with the Cosmos DB. So if I'm close to that 429, this will actually execute first, then other low priority items. So you can kind of control if you are hitting that 429 rate limit. So this is still in private preview, but it will be available hopefully soon. Now, let's see how many minutes we have. Maybe 5 more minutes. So if you have any questions, I can kind of help now, or I can actually show you something else here. I'm not sure if you know anything about the VS Code extension I have. I can maybe demo some items for you. Let me see, this is gonna be, let's see if I can share this. Sure.
Why wouldn't you use serverless in production?
You can use a serverless in production. I mean, as long as you have the right, correct request units, because it can get, usually in production, things can get busy. So you might need more resources for that. But yeah, you can use it. But most of the time, people kind of goes back to provision or other scale, so you don't need to worry about keeping up the request, how much request units you need. Yeah. So let's see here. How we can do this. 1 minute. right. All right, this is gonna be tricky, but I'm gonna make it work. So I cannot see on my screen, but I can see it on here. So in here, as you can see, this is a VS Code extension. It's free. I create for the Cosmos DB community. You can download it free. You can use it rather than the browser. You can actually pick your database here. It's gonna go and give you all the containers it has. And from here, you can easily, for example, pick here. This will actually give you how many physical partitions this container has. So you can easily see the structure without kind of, worry about which tab or button you click in Azure Portal. It can be sometimes challenging in Azure Portal. And this one is going to give you, like, for example, if I go with the top 10, let's actually run this one here. I click execute, and it's going to give you how much request units that thing needs or run for, and it return me 10 items. Well, as I said before, SDK actually is the one which is handling that because we know that we have 5 or 6 partitions here. So actually I pull much more than that. By clicking execution matrix here, you can see that we made 5 requests here. And we got 50 items, not 10. So you can easily click on this link here and see we actually got 10 from each physical partition because we did not define a partition key here. So SDK is the one which is actually eliminate 40 of them and display the 10. So that's why the SDK is going to need some resources because it does all kind of stuff out there, especially if you have group by, order by, all those are going to actually happen by the SDK. And this one is the last one actually I show you. This is, for example, in real time. You can see we are using the lower CPOS type. Let's actually execute this one here. None of them is actually my partition key, so it's going to take some time. It looks like it cost me 32.34 request units. If I'm going to actually use the computed property and run it again, the same query should go much cheaper. So it was 32.34, now it's 26. So that number can be variable depending how much data you have and if you are using the partition key or not. But that actually helps. The other thing I can probably share with you, if you go under the options here, you can click the indexing metrics here. So this is actually suggesting you indexes. So in here, if I'm going to go back and execute this one more time, let's see what it's going to say. As you can see, I have a new tab here, indexing metrics. And after this thing runs, you can see it says that you are using the owner user ID that's utilized, so don't touch it. But it looks like CP post type is not indexed. So if I put an index on it, probably that number is going to go even lower than that. So this is kind of useful. Easily you can see the actually here, let me see, indexing policy. This kind of tells you what is indexed and what is excluded. For example, score is excluded. If I'm going to put the score here, probably that's going to cost much more, and it's going to tell me potential index is the score. Rather than that, it has all kind of options, features. I'm always kind of working on this. I'm hoping to actually make it open source so everybody can kind of help, because now, believe it or not, I have like 11 or 12,000 downloads on it already, and people are kind of saying all kind of stuff to me, but I don't really have that much time. So I'm going to hopefully make it that open source this fall, and it's in JavaScript since it's a VS Code. So if you, I guess, up to it, I would like to get help from you. So, but that's all I have for you today. I hope everybody learned something new, and thanks again for coming to my session. Yeah, I enjoyed it. Thank you very much. I can answer any questions you have, because since this is the last session, we're done. Sure. Sure. Can you say your question one more time? Okay.
Should I really pay attention to convert that to the composite index?
So that really depends. First, depends on how big your database is. So if your database is pretty large, it will help you dramatically. Because, when you make that call, then that means it's gonna find that index in one call rather than 3 times. It's gonna be like, when I cover the range indexes, that means that you have that index available in 3 places. So when you make that composite index, it's gonna find it with one call, it's gonna be much faster. But to see that dramatic change, you need to have a lot of data too, because that's gonna actually make a big difference. Yeah.
One more thing, I really find it very useful to play around with the Cosmos price calculator when I was struggling how to optimize the cost. And then I find out that, for instance, increasing size of the document reduces significantly the throughput, the request unit spent
Correct.
for instance, upsell operation, right?
Correct.
So because of that, I decided to put more documents in the group. I grouped them into the bigger chunks of the documents. So that was also something very nice to learn.
Sure, yeah, that's a good feedback. And also, whenever it kind of gives you a good number, but in the meantime, when you select, try not to select everything either. You know what I mean? Because the number is going to give you, if you have like 200 properties, for example, and if you only care about the 3 properties, you can easily just say, select 3 properties. That's going to make the request unit much smaller too. So that calculator is great, but it calculates for every properties you have. So whenever you try to query the data, I guess, try not to say select all, because that will actually help you with the request units. That's one of the, I guess, good tips too. Yeah. Yeah, no, thank you. Thank you for coming. All right. Thank you, everyone.